Good morning, everyone. What we're here to do as professionals is to look at what others have done, learn from their experiences to avoid problems, and put that into practice in our own operations. In my mind, that's called wisdom. But we need to go a step further. In any continuous improvement process, whether you use 8D problem solving or another approach, the focus is first on containment of the problem. Then the focus turns to prevention. We need to change future vehicle designs to eliminate the issues that we see today. And that's the purpose of the Future Truck Group. I'm often asked, what is TechIM? We consider ourselves to be business accelerants, driving businesses to achieve faster, profitable growth. We get you more money from your business and more time for your life. Using a holistic approach, we look at 7 different forces that are affecting every particular business and try to align them so that you're going to get an improved operation. Technology is often a force of change in every business, both internal to the company and external to the company. And so I often say, savvy technology creates powerful results. And savvy technology, as you will well understand, is the right technology at the right time for the right cost, properly employed so that you get the kinds of financial results that you want in your business. What we do, in short, is work with companies to create a 3 to 5 year long-term strategy for growth in the long term and do business consulting to help them with the short-term results. Last year, we worked together with the Technology and Maintenance Council, with the American Trucking Research Institute, and with fleets throughout the country to find out from them what they thought the future was going to be roughly 10 years from now or longer. We talked to 32 executives, 15 of which were CEOs or presidents of the fleets, a number of which were fleet maintenance managers, and one which was a service professional. I'll present some of those results today. I encourage you to look to the complete report and presentation that I made at the ATA Management Conference and Exhibition. We also created this document, which you can download from trucking.org, or you can get a hard copy of it. In the book, you will see this page on future expectations for fleet maintenance management. We are only in the starting phase of remote diagnostics, and you can bet that it will grow in the future. It's going to enable more data to be analyzed to support the predictive diagnostics and condition-based maintenance that we've often dreamed of. And why is that? We asked how wearables, gesture controls, virtual reality goggles, 3D additive manufacturing printers, and much more change the face of maintenance. We know that technology is going to continue to grow in the new vehicles that we're buying. The vehicle OEMs are driven to accomplish that because of safety regulations, because of emissions regulations, because of the fleet's demands for improved productivity and lower costs of operation. What's going to happen then when we take a global operation and have standardization across the world that the OEMs are going for? What's going to happen to you and how you're doing maintenance? What's maintenance going to be like 10 years from now for you? How are you going to handle it? And how can we as an industry influence the vehicle OEMs and the Tier 1 suppliers to make the improvements that we need out in the shop? It should come to no surprise to all of you fleet maintenance executives that the response we got to what they're going to do for maintenance 10 years from now is, what maintenance? We're not supposed to be doing any maintenance. Trucks are not supposed to be in the shop being repaired or even having preventive maintenance done. A shop in the truck is extremely safe, but it gets exactly 0 miles per gallon in fuel economy and accomplishes nothing in terms of delivering freight and producing revenue for our companies. So what are we going to do that's going to drive things so that we can accomplish this with no maintenance? It's a great goal, but it may be slightly unrealistic, but I'm sure we can get a lot closer to that. One step in that direction is to renew an effort that we've had for probably on the order of 20 years. We still need all of the different tools that a service technician works with to be integrated together. I'll bet that you're still running multiple updates of software on at least a quarterly basis, if not more often, on multiple programs. That's so 1980s technology. We need to get to where we have one system that you've all wanted that interacts in one way to be able to do all of this. We talk about having over-the-air updates for the transmissions and the engines and the electronics. yet we still struggle with, probably some of you are still using disks of some sort to update the software in your off-board computer systems for service. What we need to do is get to where a service technician can be having their head under the hood of the vehicle, looking at what's happening, and then have glasses tell them what needs to be done. You'll see something at the end of this presentation that shows where a passenger car OEM is taking some important steps in that direction. We want to make it easy for a service technician to do things because it's so complicated. We've got to have the capability with artificial intelligence and guided diagnostics in order to help the service person accomplish things. I use YouTube to figure out how to service things as simple as changing a light bulb in my microwave oven. I'll bet you're doing some of it too. One of the ways that we're going to be able to accomplish this is if we aggregate all of the service information and failure information that we have in the industry. Right now, we have some leading fleets that have some really good information. We have other fleets that don't have good information. I'm sure you've all had times where an OEM has said to you, well, I never heard that problem before. Nobody's ever had that problem before. You know it's not true because you've talked to a friend who has had that problem. If we can aggregate all of the information together, then we have a better chance of doing the big data analytics, the predictive diagnostics that we're talking about, and the condition-based maintenance, because we'll have the raw data that we need to put into those computer algorithms in order to figure out what we need to be doing, and not just repairing it, but what we need to do to fix it in the future with a new vehicle design. Those are three big items that we need for the future in order to be able to handle service. Commercial vehicle OEMs continue to move forward offering more integrated products. All manufacturers now offer proprietary engines. Half are offering proprietary transmissions and some are offering axles. The traditional ability for a fleet to specify individual components and the suppliers of them is changing to where a fleet chooses a package of products and services that has been tailored to benefit the fleet, as well as allowing the vehicle OEM to meet those stringent government regulations, limit pollutants, and increase the freight efficiency of the vehicle. We asked what products, services, and options do you expect of vehicle OEMs in the coming decade and beyond to improve your operation? Vehicle OEMs have to continue to integrate their sensors and their safety systems. They need to do it to meet the vehicle performance requirements that we all demand, to meet the safety requirements that are put out by the government. They need to meet the emissions regulations. They need to decrease the fuel consumption so that we get the lower cost of operation that we need. And they need to deal with product liability. And so they have to take more responsibility for integrating the sensors and the safety systems and control systems on the vehicle. This in turn means that the OEMs have to take more responsibility for doing the service diagnostics. We cannot have the vehicle OEM pointing to the Tier 1 suppliers or multiple Tier 1 suppliers pointing at each other. We need the OEM to take full responsibility for the diagnostics so we can keep those trucks on the road. This process of getting more complicated vehicles out and having the OEM take more responsibility has brought more non-product people into the process of being able to service the vehicles. We have many more IT people at the vehicle OEMs who have to be involved in making sure that all the service systems are in place to be able to make this stuff happen. And the last thing that we need is to have a couple of IT people pointing at each other saying, it's not my fault with my computer system, it's your network that's the problem. Our job is to keep that $125,000 truck or more expensive out on the road producing revenue for us, not having people point fingers at each other. As an extremely important step in being able to diagnose and repair vehicles in the future, the industry this last fall or early December decided that they would make all of the service information from the vehicle OEMs and the Tier 1s available on some sort of a basis. Our industry needs to take that important agreement and make sure that that gets fulfilled and everything is available at a reasonable cost with all the kinds of training that we need so that we can get these vehicles repaired in the future. Service technicians generally have a much easier time figuring out when something is broken. They have an easier time figuring out when there's a hydraulic leak or an oil leak or a fuel leak in a vehicle, which they can see. They have a much harder time seeing an electron leak in a wire. I can only imagine how difficult it's going to be when they're having to diagnose software problems, or we have a lot of wireless situations with the telematic systems, with the vehicle-to-roadside communications, with the vehicle-to-vehicle communications. It's going to get much harder for a technician to be able to diagnose our vehicles without some sort of help from a lot of computer systems that are going to be extremely intelligent. I expect most of you have heard of the Internet of Things, or IoT. I prefer to think of that as IoT standing for Information on Trucking. It's powered by information that can only come from hundreds of sensors. Yes, sensors. They're a pain for reliability and durability, so we need to work on them to make them better. We can't have information without the sensors. We need sensors for temperatures, for pressures, for position. The cameras are sensors. We're even going to see micro-machined spectrometers on vehicles to do chemical analysis in the future. We have heat at the wheel ends. We have engine oil sensors, brake stroke sensors, haptic feedback sensors for steering wheels and the seats. All of these are needed in order for us to get to the information we need to make decisions. We need to make those super reliable so that they don't add to the problem of diagnostics and failures in our vehicles. One area that seems to need particular attention is the area of communications between the tractor and the trailer and other vehicles. 30 years ago, we developed a standard within this industry to do diagnostics. 20 years ago, we developed a new standard for controlled communications on the vehicle. We've sort of lived out the usefulness of those particular items, and the vehicle OEMs are moving to more proprietary standards. We need a more industry standard process that's going to get us to maybe 4 different areas that will have communications. One is on the tractor, so that we have more standardized communications among all of the different things, yet safe and controllable for the vehicle OEMs. 2, the trailer is becoming much more important. It's very common now for a trailer to have 3, 4, or 5 computers of its own on there and having to communicate among them, say the refrigeration to the trailer diagnostics, to a ABS unit, to a trailer telematics unit. The diagnostics needs to be improved because we have many controls that are behind proprietary data links now. And we need to make sure that all of the information that's needed for diagnostics comes across from those through a gateway out to your service equipment. And then I'm pretty certain that we need something additional for the camera now, because we have so many more cameras going into the tractor for monitoring the driver, for monitoring the lanes. I expect we will see cameras in the future with this 360-degree bird's eye view and for backing maneuvers. So we need areas of new communications, and this industry needs to take the lead in developing the standards for the future that's going to include communications between the tractor, the trailer, on the trailer, and between the combination vehicle with the rest of the world. Omnichannel is not another TV channel on your cable or satellite video system. I think of it as the AAA expectation of customers for fast delivery of anything, anytime, anywhere. It means all of us have to jump higher to meet expectations. It also means we have to go higher due to the expectations of the electrical system on the vehicle. Passenger cars and commercial vehicles in North America operate primarily on a 12-volt electrical system, whereas agricultural vehicles, off-road vehicles, buses, and military vehicles often operate on 24 volts. A large segment of the world's commercial vehicles operate on 24 volts. Passenger cars are migrating toward 48-volt hybrid systems that allow the engine to cease operating at traffic lights and stop signs, thereby capturing fuel savings. Higher system voltages reduce parasitic electrical loads, eliminate mechanical loads on the engine, provide greater fuel economy, and reduce CO2 emissions. Fleet leaders do expect that we're going to have to go to higher voltage in the future. 15 of them said yes, 6 of them said maybe, 7 no, and 4 had no opinion. In this time of political polls and elections in the Iowa caucuses and the New Hampshire, that's a big winner. 65% were in favor and only 22% were against and 13% undecided. That's a winner, and that tells me that this industry will move to higher voltage in the future. But what are we going to do? We know that you can't run your laundry dryer off of a 12-volt battery. We don't even run it off of 120 volts AC. We run it off 240 volts AC. So the question is, what should we be doing for the future for the voltage? Is 48 volt too high? Is 24 volt just right? 12 volt we know is too low. Where do we go in the future? We've had 12 volt or 6 volts for about 70 years, then we've had 12 volts for nearly the same amount of time. When we get to the year 2100, or to be able to last that long, we need to be careful in what voltage that we choose. We don't want to be like a novice who's doing clay pigeon shooting and shoot where the pigeon was and never be able to hit it. We have to anticipate what it's going to be in the future and shoot for where the pigeon is going to be. The other thing we have to do is have a transition plan to get there. We've started discussions at the SAE technical level, and we've started some discussions with the Truck Engine Manufacturers Association, Truck and Engine Manufacturers Association, to begin figuring out how could we transition to a higher voltage that will take us to the year 2100 or beyond. Let me turn to a few more items that I expect to be commonplace in the service bay of the future. Thermal imaging is now available at low cost and can even be attached as an accessory to a smartphone. The top left picture shows detecting heat loss through an area that is unsealed, something that could be applied to the seals on doors and windows of truck cabs. Imagine being able to detect a poor electrical connection by seeing the heat generated as shown in the upper right. The picture in the lower left shows detection of problems with heating pipes that could be applied to radiators. The technology will go even further. I'm expecting a smartphone to be able to take a picture of a tire's tread wear pattern and automatically provide guidance on problems with the chassis. We've been using level sensors for years. They range from a very simple dipstick for engine oil to an electronic ultrasonic-based sensor for fuel level. This is a picture of a diesel emissions fluid quality sensor. You may have seen one already. I believe this is where we're going to be going in the future, is having more quality sensors, not just fluid level sensors. This second picture shows a sensor that has CAN-based electronics in it and software to be able to begin testing and sensing what's going on with the quality and multiple parameters, viscosity, level, dirt, etc. It uses a micro machine sensor, and with the software is able to begin doing the correlation between different values that it's measuring to be able to determine what's going on with the vehicle. This is what I think we're going to see more of in the trucking market in the future. This third picture is of a spectrometer on a chip. It has a laser capability and micro machine sensing to be able to detect the quality of a sensor. So I see it as the same sort of things you do today where you take an oil sample on a vehicle, send it off to a lab, they run it through a spectrometer and send you back information on what's going on. I believe in the future we're going to be able to do that on the truck with a device like this, and it's going to be able to go through the telematics system, either the fleet management system or the vehicle OEM's truck diagnostic system, to give you information about what's happening with your vehicle and what you should be doing to make it run better. Many people are wary of autonomous vehicles and drones, but I think there are some amazing applications for them. Drones are now being used to be able to inspect bridges. That not only is fast and easy to accomplish, but it also is going to help the traffic situation. We no longer have a bucket truck with multiple cones slowing down traffic, perhaps causing accidents of its own in the process. We don't have a person up in the bucket that is at risk for a variety of things up there. That's a good application for a drone. What if there was an Amazon type of shared service whereby a drone could be put out immediately to the scene of an accident to assess what's going on? And imagine it goes even further, that an autonomous vehicle tow truck then goes out to rescue the vehicle that's out there, and you know exactly what you need to do with it as a result of having the information that you need from sensors, including the cameras, that are going to drive the autonomous vehicles and the drones. Drones are being used to be able to inspect roofs on a variety of buildings. Much safer way of accomplishing it than having somebody go up, especially if it's a tile roof that's very slippery. Even an asphalt roof is a problem, or a cedar shake shingle roof is a problem. So what else could a drone do for us in the trucking industry? Could a drone do some sort of inspection of trailer damage on the roof or on the top portions of the trailer? Could we create a drone and a new lighting system where the drone could replace the lights at the top of the trailer and not have to have somebody get up on a ladder and risk injury? One of the biggest injuries I know that occurs at a lot of fleets is an OSHA compliant problem like that, where somebody falls off of a ladder. Let's get rid of that in the future with how we design things and how we use technology. At the Consumer Electronics Show in January, an automotive manufacturer announced an instruction manual on a portable device that uses the rear-facing camera to automatically identify the parts of the vehicle. Imagine if the parts of an engine could be automatically identified by a smartphone or tablet, even in the presence of grease and dirt. Further, imagine glasses on the technician that do the same thing, walking her through the repair procedure. Now, I don't know about you, but I find myself using YouTube videos to help me with servicing everything from replacing the battery on my fancy key fob for my car, to the filter in my new refrigerator, to how to operate my new camera. The key is to have the device in front of me while the video is playing. Future service technicians will have this, and we absolutely need this with the complexity and variation that they face. There's really so much more to the service shop of the future. What I'd like to see is that you prepare for it. Get started now. I'd rather see you make the changes and be prepared for the future rather than responding to the future when it comes and having to deal with it. One of the important things that we need to do as an industry is to aggregate the information that all of us have in our different fleets, put it together into one database that we can use to mine information for the predictive diagnostics, predictive analytics, the condition-based maintenance systems. Our industry, this trade association in particular, should play a role in defining what information needs to be into there and helping define what information comes out of it, how it's presented, and what we do with the information. Let's get started with a study group devoted to this particular task. I'm not sure which one is appropriate, but let's get started in defining what we need for information that's aggregated in some fashion that protects the necessary privacy. The second thing that this industry needs to do is recognize that we're going to have a higher voltage. The 12-volt system that's been around for on the order of 60 years is not going to be the voltage that we're going to have 75 years from now. We need to take action to prepare for that, decide what is going to be done, decide what a transition plan should be to get there. It doesn't have to be an all-in change in one particular year. With the changes that are coming in emissions regulations in 2024, 2027, the fact that we'll see a bunch of new vehicles introduced probably this year for the 2017 regulations, and probably in 2027 or 2024, we'll see another set of new vehicles from the vehicle OEMs. Let's take this opportunity to define what we want for a future voltage and how we're going to get there by working together with the fleets that are in the Technology and Maintenance Council, with the Truck and Engine Manufacturers Association, and with the technical people in the SAE. Thank you for listening. I hope that you've got some ideas of what we need to do in the future. My job is to make sure that the future is bright, that we're driving towards faster profits in this industry, that we have savvy technology that's going to create powerful results. Let's take this opportunity to change the future, not just respond to it. Thanks again.